So it's a very great pleasure to introduce my wonderful colleague, Annette Zimmermann, who's lecturing the philosophy department and joined us in September 2020. So Annette's current research focuses on the political and moral philosophy of AI and machine learning. And it's this that she's going to talk to us about today. Over to you, Annette.
Hey, thank you very much for having me at the YorRobots seminar. I'm excited to get to know this interdisciplinary community. I'll now share my screen with you. I brought some slides for today. Okay, so as you can see, this project is about a concept that I call decision landscapes in the context of contemporary debates on algorithmic fairness. Now, while my own research focuses a lot on algorithmic decision-making systems and machine learning systems, I do think that the arguments that I'll be talking about today might apply even more widely to all sorts of socio-technical systems, because as you will see, whenever technological models interact dynamically with the world, that has very particular implications for how we as human decision makers ought to respond to them. Great, so here's a quote from Yes Minister, just to get us started. Very often when we're faced with complex decision-making scenarios, both in terms of human decision-making and machine decision-making, we kind of encounter scenarios of the following kind. So here the characters in Yes Minister say, in stage 1, we say nothing is going to happen. Stage 2, we say something may be about to happen, but we should do nothing about it. In stage 3, we say that maybe we should do something about it, but there's nothing we can do. And in stage 4, we say maybe there was something we could have done, but it's too late now. So this is the kind of decision sequence that often leads to very pernicious outcomes. Very often we can be in a particular time slice and have an assessment of what is feasible right now and which ideals should be guiding us. And we can end up with really bad and harmful and suboptimal results. Now, here is an overview over the main claims that I want to make today. So firstly, I think that much of the literature on algorithmic fairness has focused a lot on optimizing for decision quality. So we can see why that's true when we look at all of the recent work on formal fairness metrics, for instance. So all of that work is incredibly valuable, but it focuses in particular on the question of what it would take to optimize a system that we've already chosen to deploy. How do we make the decision quality, the kind of informativeness and the accuracy of the outcomes of a given algorithmic systems better by the lights of particular formally defined fairness metrics. Now, assessing the quality of algorithmic decision outcomes is really, really important, but I think it's actually insufficient for assessing algorithmic fairness in a more full way. I think that in addition, we should critically scrutinize our so-called decision landscape. So that means we need to ask questions like which alternative decision outcomes are actually available to us? And even much more crucially, which alternative decision problems could and should we be solving with the help of algorithmic models? Finally, I think that considering decision landscapes in conjunction with these really important decision quality questions will have implications for the question of whether we ought to deploy a given algorithmic tool in a given domain in the first place, so at all. In particular, if optimizing for decision quality in a problem space, what's called P1, moves us further away from justice or other important normative or ethical values, we should actually decide to solve a different problem P2 instead. We shouldn't only think about, well, how can we make our decision quality for P1 better? We need to just consider a much more fundamental shift in our perspective. So here's the plan for this talk today. I'll talk a little bit about the ethical baggage that is attached to making design and deployment decisions. So contrary to our frequent assumption that technological design and deployment choices are inherently neutral, as it turns out, very many of them have really significant ethical and political implications. So it's very hard to get rid of this normative baggage. I'll then introduce this thought about decision landscapes in a more structured way by looking at 3 different arguments. in this area. I call them respectively the benchmarking argument, the A-leaves argument, and the quality independence argument. Before concluding just with an applied example of a recent case that I think really illustrates why looking at the decision landscape, so asking the question, what's the right problem to solve, in much more detail. Great, so let's start with a very basic intuition that I think is actually probably subject to widespread agreement across different disciplines, but often still insufficiently acknowledged. That intuition is that designing algorithmic systems, or indeed any form of technology, means making explicit and implicit choices that have ethical and political significance. So in terms of design choices, I'm thinking about things like unstated assumptions, when it comes to narrowing in on a problem or making decisions about what the most important problem to potentially solve might be. But also the problem of defining contested or inherently fuzzy concepts. So think, for instance, of algorithmic recidivism risk prediction systems that necessarily have to define some notion of a high-risk individual, a high-risk defendant. Of course, there's many different ways of cashing out exactly how we should measure high risk in this area. And some of those metrics will be subject to quite significant moral and political disagreement. Similar problems occur, for instance, in a hiring system, in which we necessarily have to come up with a good conception of what a weak applicant looks like and what a strong applicant looks like, right? So which metrics should we be using in order to classify people in that kind of context? Similar problems occur at virtually all design stages, so collecting and labeling data, selecting decision rules, and deciding exactly how to abstract and idealize when we develop a technological model. Everywhere in this machine learning loop, or in an algorithmic decision-making system loop, we will be making all of these judgment calls that inherently replicate ethical and political views. So for instance, if we come up with an algorithmic fairness metric that tries to formalize some notion of equality of opportunity, but not equitably adjusted decision-making outcomes, we've already made a decision for just how much we want to optimize for outcome equity, right? And so we might be falling short of some type of ethical goal that we might in fact want to pursue there. Similarly, deployment choices also have this kind of baggage, right? So if you think about not only the choice where and when to deploy and which validation and verification methods to use, but also larger scale questions surrounding this issue of who actually has a say in deployment decision. So is it a private corporation making the decision to just deploy a system and see, if it's useful, or a government or a democratic constituency making that decision to procure technology to use in the context of a given public institution? All of that will have very different ethical and political implications. So that again motivates this very basic intuition that we started with, and that it's really hard to opt out of making choices that are already ethical, already political. So we can see here that when it comes to identifying the success conditions for technology interacting with our social world in a just and otherwise beneficial way, we really have to consider this interplay between the technology itself and the context in which it's deployed, right? These model world interactions are ineradicable, also because the kind of social meaning that is attached to making particular judgment calls will be heavily dependent on a given social context in a given point in time. Great, so this brings me to my second basic intuition, and that intuition is that if we can choose, if we can make these explicit and implicit choices, we're automatically on the hook. So we're responsible for whatever outcomes we get from these systems. That doesn't only include developers and researchers, as well as the corporations who are able to provide these systems. I think it actually also has larger scale implications for society. I think that, for instance, a public official who is in charge of deciding which particular algorithmic tool to use for a given decision task, that person has made choices that render them ethically responsible, at least in part. for some of these outcomes. So you might now wonder, well, how to live up to this fairly diffuse ethical and political responsibility, especially in these situations where responsibility is kind of splintered out across many different groups in society. I think at the most basic level, it just means that we have a moral duty of justification to each other. And meeting that kind of duty, I think, will necessarily require being very clear about the nature and scope of the original decision problem that we were trying to solve. So asking questions like, what was the goal of using AI for this particular task in the first place? And to what extent have we fallen short of that originally defined goal? And associated ethical and political values. So for instance, you might look at the recent controversy in the UK about using a very crude algorithmic system to determine final grades for high school students during the coronavirus pandemic, when final exams were simply canceled. We might look at that case and think, well, what were the original goals that we were pursuing in this domain? Well, we wanted to create outcomes that reflect an accurate prediction based on prior performance. We wanted to be fair, so we didn't want social demographic features of different students. So for instance, which school are they going to, who are they as a person? We didn't want that to affect those predictive outcomes. So given that we then saw quite significant disparities between, private schools and, state schools, we might look at that and think, well, have we actually optimized for all of these goals? We seem to have fallen short in quite significant ways of those goals in various domains. Okay, so in order to tackle those kinds of cases, I think we need a framework to kind of analyze these kinds of issues in a more structured way. Looking at all of the explicit and implicit ethical choices that we make when we design systems, we can kind of sort them in two different directions. So all of these problems that I've mentioned before have to do with optimization in a way, right? So they have to do with making decisions about defining key concepts or coming up with decision rules in a way that really improves the decision quality of a given technical system. But we could, of course, also reconsider that original decision problem that we've set out to solve. So again, in thinking about the off-qual controversy in the UK, we could have also asked not only, do we need to build in uncertainty estimates into the system? Do we need any sort of oversight? Do we maybe need different decision rules? We could have also asked, well, should we be predicting final grades based on the 2 prior years of performance in the first place? Or should we come up with a different system of determining these final outcomes? So that first kind of cluster of interventions that we might make, we might classify as solving problems in the right way. So we're fairly confident we're solving the right problem, but are we going about that in an optimal way? Whereas the second cluster of considerations is more about the question of whether we're solving the right problems. So the latter is what I want to call decision landscape considerations. So I think that these are really important questions, although they're also a little underappreciated at the moment. As I mentioned before, the bulk of algorithmic fairness work really focuses on the first cluster of questions. So I think this can be a really useful addition to that kind of important body of work. So in general, I think there are 2 distinct ways of responding to cases in which algorithmic systems or AI systems lead to bad outcomes, right? The kinds of situations in which we fail to really optimize for decision quality. So when we're confronted with that kind of situation, we can either just say, let's continue to optimize. So let's stay in that first cluster of considerations. So we can say, let's incrementally optimize this AI system in order to make it more accurate, more just, more transparent, more trustworthy, more explainable, etc. So we can plug in a whole bunch of important normative values here that we might be interested in optimizing for. But we could also choose to not deploy, either temporarily or permanently. So that would be a strategy that says, because there are these demonstrable bad outcomes, either we regulate this domain or audit it in a kind of meaningful way, or we simply stop deploying. So of course that could be combined. So in many different recent applications, the providers of various technological systems have actually said, we're just temporarily not going to deploy those systems until we have really meaningful regulation in this area. So here's an important feature of this distinction. And we'll come back to this in a little while. I think it's really important that we don't evaluate these two distinct strategies purely by reference to some sort of end state ideal, so something that we ultimately want to achieve. It could be a conception of justice, or it could be some other normative ethical ideal. I think we should also evaluate these two strategies with respect to whether pursuing them would enable us to transition towards that end state ideal in a just way. So it's much more about the process of really approximating these ideals rather than simply looking at ultimate outcomes here. So my background view on this question is that, again, the bulk of existing research, both in computer science and in philosophy, actually does focus on purely articulating these end state ideals. And so that is presented as a solution to these kinds of bad outcomes cases. And so that looks like only part of the story. I think both of these different fields actually lack a good theory of transitioning towards normative ideals in a justifiable way. So here's an added challenge. Of course, we know from computer science research in this area that a number of pro-tanto plausible end state ideals are often just impossible to realize fully. So the computer scientists among you will have heard of mathematical impossibility theorems in this area. So for instance, we know that when we try to optimize for decision quality in many existing algorithmic systems, we can't at the same time equalize odds across all different groups and adhere to a number of other plausible formal fairness metrics. So perfection in this area is impossible just mathematically. So we really need to think about, what mode of approximating ideals, or what mode of making choices about ethical priorities is really the most justifiable. But consider also that even if we don't face these kinds of problems, right? So even if we don't have an impossibility result, we might wonder whether there might be some costs to incremental optimization. So consider, for instance, a society that is faced with really a deeply entrenched systemic injustice. And so in that kind of society, you might think, well, we could assist our existing police force by having a really, really powerful, highly accurate facial recognition tool that law enforcement can deploy to try to catch criminals in that structurally unjust society. But you might worry that actually rendering the existing institution of law enforcement in that kind of society more efficient might not ultimately get us closer to social justice, all things considered. So perhaps other social and political changes are necessary before we try to incrementally optimize a particular technological tool that we're going to deploy in that domain. So my goal today is to critique a blanket endorsement of the optimization strategy. I don't think that incremental optimization is always objectionable. Indeed, often I think incremental optimization is the best possible option. We have to move in closer to justice. But it's not always the case. And I think that view is underappreciated in many parts of the technology community. Not necessarily in academic research, but certainly amongst practitioners. I think there's a really prevalent assumption that any sort of minimal improvement that we can make is a win for us. rather than questioning the deeper idea of the purpose of using technology in a specific domain. So why does all of this matter? Let's look at some different arguments about scrutinizing decision landscape, just to illustrate a little bit more why these considerations can yield really interesting and important insights. The first kind of argument I want to talk about is the so-called benchmarking argument. So just to illustrate this with a really, really familiar case, think again of algorithmic recidivism risk prediction, tools like Compass. And so one argument that we often hear about these kinds of cases is that these kinds of systems just get us closer to optimizing for some important normative value. So let's say equal treatment for all those subject to a system of laws in a particular domain. And so that kind of algorithmic system will just outperform human decision making. It'll just make it marginally better. Why would we think that? Well, we have empirical research that judges give harsher sentences before they've had their lunch. So you might become quite concerned that actually human biases are really entrenched, and they're a problem that we can't easily fix or get rid of. So if we then know that an algorithmic system outperforms that flawed and biased human decision maker, it looks like a really strong case, right? So we should clearly prefer the algorithmic system. Now, that is usually presented as an objection against a non-deployment argument. So against the argument that says, no, let's not deploy this kind of tool right now, given that we've also seen that Compass exhibits certain biases. So in the case of Compass, a lot of researchers have argued that it fails differently for different defendants, and that these differences in errors actually coincide with larger structural inequalities between different socio-demographic groups. Now, we could have a particular decision landscape in mind here. And so that kind of decision landscape looks something like this. So our idea is, well, we want to optimize for equal treatment under law or some other really important value that might govern our decision making in the domain of criminal justice. And so we've already decided that we're going to get closer to that important ethical value by solving the task of predicting recidivism rates. Right? So we've already made the decision that what we need to get closer to that value is to get a clearer picture of who will likely recidivate, and that will inform our sentencing decisions. And we now also assume that our two options for performing this decision task is either we use an algorithmic system or we use a human judge. And so if we have that kind of landscape in mind, it's very intuitively appealing to say, no, if the algorithmic system gives us an incremental improvement, a way to incrementally optimize our decision making in that domain, we should clearly prefer that one. But of course, we could also have a wider decision landscape in mind. So we might think, well, holding constant this ultimate ethical goal that we're trying to optimize for, so equal treatment under law or a well-functioning criminal justice system, which other types of decision problems will we need to solve in order to really approximate that value? So of course, predicting recidivism risk in order to inform our sentencing decisions may be part of that. And we may use a technical solution or a human solution for that. But there are also larger scale social reforms, institutional changes, legal changes that might have to coincide with that in order for that kind of decision scenario to really have meaningful implications when it comes to approximating our ultimate ethical goal. So we could make a lot of different choices about which other decision problems, P2, P3, and so on, we could solve in conjunction with solving a problem like P1. So scrutinizing this much more complete decision landscape might tell us that actually we might need to reprioritize. And so maybe P1 is not the most important or urgent goal that we need to optimize for in this domain. Now, of course, one way of kind of expressing this more narrow decision landscape, perhaps in a more abstract way, is to say, well, given that we've already decided that we're going to solve this very narrowly defined problem of predicting recidivism risk, we're implicitly saying, well, we must just make a decision about that. So the only remaining decision for us is, should we pick outcome X or outcome Y, right? So should we pick the human decision maker or the socio-technical system? Now, I think it's really, really important that that's not the only instance in which we've actually failed to consider the full decision landscape. Of course, it's the kind of paradigmatic case of failing to consider the whole range of possible decision problems that we could be solving. But we could technically be aware of all of these other decision problems. So, institutional reforms, legal reforms, but we might not have really considered how to actually solve these decision problems, either via technology or via human decision makers. So a mere awareness that these other problems exist isn't really enough to really meet our duty to think seriously about the decision landscape in this area. It's important, I think, that we acknowledge that, again, scrutinizing decision landscapes can entail making these really tricky ethical judgments. And often we're not quite aware that we're making these ethical judgments when we're thinking about our possible decision problems. Philosophers have sometimes called these kinds of judgments crypto-normative judgments because they're not quite readily apparent as ethical choices that we're making. So it's often the kind of claim that follows the structure of, it's not that I think that solving P2 or P3 isn't the right thing to do. Of course, that would be preferable to just predicting recidivism risk rates. It's just that, doing that isn't really possible in these circumstances. And, just predicting recidivism risk is a really easy thing we can do right now to get us a little bit closer to justice. So in framing the decision landscape that way, again, we've made this kind of hidden ethical assessment of what is feasible and what we should do in light of these feasibility constraints. So how we should modify our ethical ambitions in light of the fact that certain things are harder to do than others. Here's another argument about this. So philosophers have talked a lot about so-called beliefs. So these are belief-like mental states that can move us to action, even if they actually conflict with what we explicitly believe. So the danger here is simply that we might be making an implicitly misguided assessment of the meaning of having solved a given decision problem, P1. So what I have in mind here is the kind of case where we choose to solve a given problem, we choose to solve it via the use of an automated system. But then we form these other implicit beliefs about what having this kind of information means. So to stick to our previous examples, we might have the explicit belief that we're just predicting recidivism risk rates, but implicitly we might be forming the assumption that actually now that we know who's a really high risk individual, that might also help us solve a whole range of other assessments that we might make in society, maybe beyond the criminal justice system. And so that could have pernicious social effects if we're unaware that we're actually forming these other beliefs. Often an added problem here is automation bias. So of course we know from empirical research that human decision makers tend to give undue credence to decision outcomes that are presented in a quantifiable way, particularly when they're generated by an automated process. And so given that we know of the presence of automation bias, and we also know about this danger of forming these implicit kind of mental states, I think we should be quite cautious in terms of responding to algorithmic outputs. Okay, here's the final set of claims that pertain to scrutinizing decision landscapes. I call this the quality independence argument. So I think that our duty to scrutinize decision landscapes may actually conflict with our duty to optimize for decision quality in accordance with some set of ethical values. So here are some reasons why it's plausible to think so. First, consider phenomena like status quo bias. So people often prefer the decision landscape that they have now and that they know about, and they will perceive alternative future decision landscapes that potentially include new problems that we could be trying to tackle as a loss no matter what. And so that will have really important pragmatic implications for whether political deliberations about the deployment of a given system are in fact going to work well, whether people are in fact open to that. And so that might undermine our ultimate duties of justification in this area. Similarly, people may just prefer less ambitious goals because often we think, well, we should try to fix things that are feasible to fix right now. And we can think about these larger scale structural problems later on. And so all of that might really prevent us from truly scrutinizing the full range of available options. And to make matters worse, of course, sometimes we don't even know what's feasible. So there might be other possible solutions that are available to us while we innovate and while we develop new technology that we can't all neatly foresee. So here's an illustration of what I have in mind. Consider, again, a kind of decision landscape in which I have a fixed decision problem, P1, which you see in your lower left corner. And then there are a number of really important ethical values that I could be trying to optimize for. These are very different ethical goals. So there could be some very feasible but smaller goals, let's call them N1. So that kind of normative value we can approximate quite easily and quite quickly. By contrast, there might be some goals that are just completely infeasible, for instance, because there are mathematical impossibility theorems, but there could also be just other forms of computational challenges, computational complexity that render some goals just totally infeasible, so something like N5. There might be some goals where we're not quite sure whether we can actually achieve them at all, something like N4, so it's kind of at this boundary. And then finally, there are these really, really big goals, like some really demanding ideal of justice, for instance, where we really equalize a lot of things in society. And so that goal will be much more optimal, all things considered, than a goal like N1. But it's also further removed from us. So it might be subject to more kind of soft feasibility constraints like investing effort, time, solving complex decision-making scenarios, and so on. And so we could make a choice about this kind of decision landscape. We could just look at that and say, let's just get N1 first, right? So let's try to achieve what's really near to us, what's really feasible. And then maybe over time, it turns out other social and ethical goals become really infeasible. Whereas less optimal goals are the only remaining things that we can optimize for, given that we've already decided to tackle a problem like P1. So as we can see here, in this kind of hypothetical decision-making sequence, as soon as we've chosen to optimize incrementally for this really not quite demanding goal N1, our really big goal N3 has really moved far beyond our reach. Whereas we could have, of course, decided to not optimize incrementally. So we could have even leveled down a little bit in the beginning. And then that big ethical goal N3 might still be within reach. Or, of course, we could have just redefined our decision problem, the methods that we use to tackle it, as well as the kind of scope of the problem that we're trying to solve. And then a goal like N3 might have been much more directly available to us. So we'll illustrate that with some applied cases in a minute. But this is the kind of abstract structure of a decision landscape.
Just mute the laptop. I'm watching.
Hi, sorry. Did anyone want to comment on any of this?
Sorry, Annette, I don't think so. I think it was an interference in the background. I muted him. Please
no problem.
Sorry about that.
No problem. Okay, so here's the kind of core upshot from this initial structure of a decision landscape. So the intuition is, if optimizing for decision quality in a given problem space P1 moves us further away from justice, all things considered, we should solve a different problem P2 instead. Let's consider an applied example of this. So most of you will have followed the controversy surrounding facial recognition systems. Now, some of these applications have much more clear ethical implications than others. Think, for instance, of the team of Stanford researchers who developed a system that claimed to infer behavioral characteristics and personal preferences purely from facial data. So in this case, eye measurements and similar data points were claimed to be used to infer the sexual orientation of various people, as well as their propensity for violent crime. And so, of course, this generated a lot of controversy. One key worry about these kinds of cases was that there is something intrinsically wrong with these kinds of applications. They carry this kind of historical baggage of eugenics and phrenology. And so even if that kind of system works really well, there is still that kind of expressivist cost of using a system that echoes pseudoscientific methods from the past. But consider cases in which the case is much less clear, right? So consider facial recognition tools that are not objectionable for expressivist reasons of this kind. So a tool where we're not using a blunt measurement of facial data to infer behaviors or preferences like sexual orientation or criminality. We're maybe trying to measure something different. And so it's not clear that all facial recognition systems therefore have the same kind of expressivist costs. So at least for the moment, let's assume that not all of these systems are intrinsically objectionable. But I do think that even if the system itself isn't intrinsically objectionable, the path that we would have to take towards optimizing that kind of system can still be objectionable. So that's a separate ethical consideration that merits further scrutiny. Here's an example. Consider optimization efforts that involve exploiting people. Sticking to the facial recognition example here, of course, we've seen a lot of recent research that contemporary facial recognition tools also show racial and gender disparities, much like recidivism risk prediction systems do. And so in light of that, multiple cities have decided to ban these tools, and even private corporations have decided to put temporary moratoriums on the deployment of these technologies. But not everybody had the same reaction. So some companies decided to simply try to fix those systems to avoid these racial and gender biases. And so the thought here is, well, what if we could just instead optimize these tools so that the deployment of those tools would just not lead to these unjust outcomes anymore? And so then optimization would ultimately benefit everyone. So there doesn't seem to be any ethical problem with optimization in that domain. Here's a very interesting and alarming case. Google was amongst those who favored the optimization strategy in this area. And so Google hired a subcontractor who approached vulnerable populations in LA, many of them from communities of color, offered people a $5 gift card and told them that they were playing a selfie game or completing a survey. The actual purpose of this so-called selfie game, though, was to record really detailed, fine-grained facial data from them in order to improve the representation of Black and brown faces in these databases, because one key assumption was that the reason why these systems failed was because people of color were really underrepresented in them. So looking at this kind of case, you might intuitively already see how this might be a case of exploitation, but let's actually take a closer look exactly what is going wrong here. So in political philosophy, my own subfield of philosophy, there are multiple views on why exploitation is wrongful. I actually am a pluralist about these different accounts, so I'm going to tell you about a range of them. So a cluster of accounts says that exploitation is wrongful if it takes unfair advantage of somebody. But other philosophers have also emphasized the specifically degrading or dehumanizing nature of exploitation. So I think actually both of these views are really plausible and compatible with each other. So there's no reason to prefer one over the other. I think an integrated account of the wrongness of exploitation that takes on board both of these views is really compelling. So here's an example that illustrates actually why these accounts are compatible with each other from a philosopher who falls into that second camp, so the degrading and humanizing camp. This is a quote from Ruth Sample. She says that exploitation involves interacting with another being for the sake of advantage in a way that degrades or fails to respect the inherent value in that being. It is this lack of respect that explains the badness of exploitation. I think that even in this quote, we can see that even though the focus of this particular philosopher is on the degrading treatment, another aspect here is the effort to take an unfair advantage from somebody else. And so that's why I think these views are in fact reconcilable with each other. Now, of course, you might think about the Google case and think, well, is it really harmful what's happening there? Because ultimately the goal is to optimize this technology. So a lot of people, when they hear exploitation, have in mind specifically the subset of cases in which exploitation is in fact harmful. So A exploits B by taking unfair advantage of B, and that harms B. And so that's not always true of all exploitation cases. So philosophers have pointed out that actually actions can be morally and politically wrong, even if they do not result in harm, all things considered, for the exploitee B. So philosophers have cashed this out as cases of mutually beneficial exploitation. Here's a well-known example of this kind of case. Philosophers call it the lecherous millionaire case. So assume that B's child will die unless she receives expensive surgery for which the state will not pay, and our exploiter A, who is a millionaire, proposes to pay for the surgery if exploitee B will agree to become his mistress. And of course, both exploiter A and exploitee B will benefit from this arrangement. Nevertheless, we have the intuition that because A is in this comparative position of power and is therefore able to take advantage of exploitee B, there's something wrongful going on, even though both A and B derive some sort of benefit here. And so that's why exploitation can be wrongful, even if it's ultimately beneficial for everyone involved. Multiple philosophers who support multiple different views on exploitation support this view. So I'm not going to go through all of these here in detail, but I'm happy to return to the nuances of these different philosophical approaches during the Q&A. The bottom line is that no matter what specific line we take on exploitation, our view is going to be compatible with the more basic claim that exploitation can be wrongful, even if it's beneficial for everyone. So we can apply that kind of thought to our Google subcontractor example, right? So this incremental AI optimization scenario that was happening there. So irrespective of whether you think that people are being harmed by Google's subcontractor here, or whether you think that they ultimately benefit, I think it's plausible to see this as a case of wrongful exploitation. So the intuition is, even if optimization is ultimately good for everyone, and of course, if optimization is good only for a few people, but not all of them, in both of these cases, we will have strong moral and political reasons, namely reasons of justice, not to actually deploy and optimize if our mode of optimization includes these exploitative acts. So I think also these kinds of cases really have implications for deeper and higher order questions of the kind that we asked before. So questions like, as a matter of justice, should we in general prefer the optimization strategy or the non-deployment strategy? And so the kind of key question here does not only hinge on exploitation. So exploitation is one really important ethical consideration, but it won't settle these questions decisively. So when we try to decide which strategy is ethically more justifiable, we can't just look at exploitation. It'll be part of the story, but there might be many other ethical values that we need to consider here. But the key question, I think, will still be, well, are we moving closer towards our ethical ideal, so an ethical ideal of justice or some other ethical idea, in a just way? So I think there is no blanket answer here. I think it's going to be really important that we make domain-specific judgments about deployability. So I don't think there's a kind of blanket principle that says that optimization is always better or non-deployment is always better. But we just need to look at the kind of context-specific decision landscape and then making concrete decisions about that particular case. So returning to this case, though, now that we've seen that there is no blanket answer, we might wonder, well, what should we prefer in this case? And so I think in this case, actually, the case for non-deployment is relatively clear, because as we've seen in this case, our path towards ethical goals in this area requires distributing the burdens that are associated with incremental optimization on persons in a disproportionate way. And so that, I think, can count as a distinct reason not to deploy right now, perhaps in the future. But even if the technological tool is not inherently flawed, I think exploitation in this domain could be a really strong reasons to hold off on deployment. This, I think, is particularly true when these forms of mutually beneficial exploitation that ultimately make these tools better already replicate existing disadvantages. So I think what many people think about the Google subcontractor case is the thing that's really offensive here is that the specific people who were being deceived and paid off with a $5 voucher were already the primary targets of unjust racial biases in these systems. And so that seems to double down on an already unjust state of affairs, which adds a further wrong to this kind of case. Now you might think, well, exploitees in this kind of scenario might actually have a duty to contribute to the optimization of these systems, right? So they might have that ethical duty to themselves and to society at large to really support the process of optimizing these systems. But even if we think that, I don't think that that necessarily grounds a duty to endure these conditions of exploitation and to, actively participate in deceptive tactics of the kind that the Google subcontractor used. So it's one thing to say we all have a duty to improve social conditions and the place that technology has in society. It's yet another to stipulate a duty to endure further injustices and disadvantages in this area. So quickly, here's the upshot of these arguments in more general terms. As we've seen, designing systems and making choices about their deployment means making choices of ethical and political significance. This, of course, includes choices about how to deal with uncertainty, about specific feasibility constraints that may or may not arise, and also about how to change our goals over time in a complex decision-making sequence, where in the beginning, it might seem justifiable to optimize for decision quality, but actually ultimately within the decision sequence, it turns out that we should change our assessment of that. Finally, scrutinizing decision landscapes, as we've seen, has implications for this question of whether we ought to deploy at all in a given domain. And the key argument has been that if optimizing for decision quality in a problem space P1 moves us further away from justice or some other important ethical goal, we should solve a different problem P2 instead. And so the surprising upshot here has been that optimization on an incremental level can actually undermine justice, whereas non-deployment could potentially promote justice in a number of cases. Okay, thank you. Looking forward to your questions.
Thank you.
Okay, thank you very much, Annette. So we've got some time for questions. Does anyone want, you can either indicate your kind of wave at me, put a comment in the chat. I will also check. Radu.
Oh, hello. Thank you, Annette. That was a very interesting talk. So I wanted to ask a little about how this set of challenges that you outlined for ethical choices and political choices differ when they are applied to algorithmic solutions compared to human solutions. And if they do not, then can we learn something from how humans manage to build acceptable solutions and decision-making systems that only involve humans making decisions and sort of retrofit those to algorithmic systems?
Right, fascinating question. So the idea is, what can we learn from purely human decision-making scenarios, particularly when it comes to complex decision landscapes?
In particular, if they are facing similar challenges, which I believe they do, but maybe you'll contradict me.
Yeah, no, I actually completely agree with you that a lot of these decision problems are structured in a very similar way. And I think the challenge here is actually that a lot of people assume that the domain of AI is dramatically different in some way. So there's a frequent AI exceptionalism going on, where I think we blow up the kind of unique features of algorithmic systems too much and forget about the parallels that we can draw in this area. It is true that some specific challenges arise in the context of algorithmic systems. So for instance, as I've mentioned before, automation bias might cloud our human assessment of the meaning of having solved a given problem via the use of technology in many kind of complex ways. But that is something that we can try to mitigate in some way. And so ultimately, it looks like decisions reached via algorithmic systems might not be fundamentally different from decisions solved by humans. Now, I think one takeaway that we can see from complex decision-making scenarios that don't involve technology is that different human decision makers interact with each other and deliberate and intervene in each other's decision making. One thought in democratic theory, which is a branch of political philosophy, is that we can either choose to intervene in a decision making process between many different actors ex post, so we can try to respond to existing decision making outcomes by regulating them, by trying to change them once they've been made, or we can take a more ex ante approach. So we can think more critically about what sort of agenda we want to set for ourselves as a decision-making constituency. And so that kind of thought, I think, is very aligned with this idea of thinking more critically about the decision landscape, in the sense that once we've already decided to go down a particular decision path, once we've already decided that this particular problem is the one we should solve and not that one, then we've already foreclosed a number of possible options. And so what we can learn from that for the domain of AI, I think, is we need to find ways of bringing in more people at an earlier stage of intervention into technical systems. So what happens right now is technology corporations, because they have the state of the art in many different domains, have the power to set the agenda. And so they have the power to select the decision problems that they deem, really useful to solve, really profitable. And so having more of a larger scale social discourse on the areas in which we actually want to use technology, I think might help mitigate that in really beneficial ways. So again, thinking about a case like the off-call controversy, or again, thinking about these facial recognition systems, or think of, for instance, algorithms used to allocate welfare benefits in public institutions. With all of these decisions, I think it would be really, really beneficial to have a wider social discourse and opportunities to participate in these decisions, to use technology in the first place. So to give more opportunities to set the agenda on a democratic level, rather than just letting a very limited set of actors decide that the agenda is to use technology in this way, in this domain, and to then try to ex post regulate. So I think we can learn a lot from much more standard democratic processes that we can kind of neatly apply to this domain as well.
Thank you, Annette.
If there are no more questions, I might quick. Oh, Anna, go ahead.
Thank you very much, Annette. I really appreciated the talk in this area. And it was very interesting for me, as you were speaking, I was with my engineer hat thinking there is no way we can solve this problem in a general way. It must be domain specific. And indeed, in the end,
yes,
you said it is domain specific. But I wonder if it's fair to ask you, what is a domain in terms of a develop? I absolutely, several things you said there resonate very well. The big problem is unstated assumptions. We need to be looking at these ethical and political requirements early on. So early on, you need to be finding out what the requirements of a system are. But do we have hope of having guidelines for domains, whatever domain is, that will mean that we can decide to start to develop our new applications and go ahead? Or every time I try to develop an autonomous system, I need a philosopher?
Yes, we need philosophers for everything, and we should be making the decisions, clearly. Okay, very good question. What is the boundary of a given domain, and are there maybe some general things that we might know about a given domain that allows us to kind of go forward and develop systems there? So the question about the scope of domain, I think, is inherently contested. Again, this is a very big problem in political philosophy. So political philosophers, for instance, have argued a lot about what constitutes the domain of the political. So like what's part of the political sphere and what's part of the private sphere. You can get similar problems with like any sort of boundary you want to draw, right? So what's the domain of the medical, given that, you know, everybody interacts with the medical system at various stages of their lives and is affected by like medical policy. Or what's the domain of the scientific or the environmental? So things are not quite clear cut. But for instance, thinking about the facial recognition case, I would define the relevant domain there as the domain of law enforcement. And so within that domain of law enforcement, there are obviously multiple subdomains. So for instance, predicting crime or responding to crime, or, you know, allocating resources. So we could get more specific there. But in terms of the ethical values that guide that domain, I think one really important thing is due process, right? So in the domain of policing and law enforcement, we really care about the fact that people are treating other people equally, as members who are equally subject to the law, right? So every member of society deserves equal treatment. And so that's why people had this really strong intuition that any sort of racial and gender bias was really ethically unjustifiable, because we have this higher order ideal for our criminal justice system that we can't deviate from equal treatment. Now, things might be different in other domains. So for instance, think about really innovative, high risk, high reward medical AI innovations. And so you might very well think that actually, even if there is a high potential for failure in some of these very new areas, there might be a stronger presumption to just deploy and test if there is a potentially really high reward. So that's why I think our judgment of what sorts of risks and precautions are appropriate might really differ from, you know, like a kind of classic public sector application to, you know, one of these, you know, more private and more kind of innovation-driven applications.
Okay. Thank you.
Fantastic, thank you. Anna, do I understand we're out of time now?
I think we are, yes.
Yeah. So I'd just like to thank Annette for a fantastic and incredibly stimulating talk. Thank you everyone for coming along.
Thank you, everyone.
Thank you. Thank you both. Thank you very much.
Thanks.
Thank
Bye.
you.
Bye.
Bye-bye. Thank you.
Thanks, Anna.
Thank you. Thank you.